In this video, I'm going to talk about gas laws. So to begin with, let's start by looking at Boyle's law. So this law states that pressure and volume are inversely proportional, are inversely related at constant mass and temperature. So this law is given by the formula P1 V1 is equals to P2 V2, where P is pressure and V is volume. But our P1 is our initial pressure and V1 is our initial volume. P2 is our final volume and our final pressure, and V2 is our final volume. Okay, so let's have an example. We see how you can use this formula in solving problems. Now, the example says a gas occupies 100 milliliter at 150 pascals. Find its volume at 200 pascals. So we're going to use this same formula to solve that problem. So to solve this problem, we're going to say our P1 is our P1 V1 is equals to P2 V2. So our P1 is our initial pressure, which is 150 kilopascals. So we're going to say 150 kilopascals multiplied by our V1 is 100. So we're going to put that 100 there, then equals to P2 is 200. So we're going to say 200, and then our V2 is not there. We have not been given. That's what we're looking for. So our P2 is not there. So we leave it like that. Then from there, we do the calculations. So upon doing the calculation, our V2 must be equals to our V2, our final volume, in this case, must be equals to 75 milliliter. We need to do the calculation. Okay, so let's also look at Charles' law. So Charles' law states that volume of a gas varies directly with the absolute temperature at a constant pressure. Volume of a gas varies directly with the absolute temperature at constant pressure. Remember, pressure is constant, so the formula is V1 over T1 is equals to V2 over T2, where V is volume and T is temperature. Remember, where there is 1 is initial and 2 is final. So for example, we have a gas occupies 473 cubic centimeter at 36 degrees Celsius. Find its volume at 94 degrees Celsius. So we have been given the initial volume and the initial temperature, but we have been asked to find the final volume given the final temperature. So we're going to use this same formula, which is V1 over T1 is equals to V2 over T2. So we are going to use the same formula, which is V1 over T1 equals to V2 over T2. Okay, so our V1 we have already been given in the question, which is 473. It's there. 473 cubic centimeter over our T1 is 36. So you need to convert that 36 into Kelvin scale. So when you convert that, you simply add a 273 to 36, and then you'll get our temperature in kelvins, which is 309. Okay, so which is equals to our V2. So our V2 in this case, that's what we are looking for. Remember, they say find its volume. Find its volume at 94 degrees Celsius. So that's what we are still looking for. So we're going to write it as V2 there. And then our T2, it's here, which is 94 there. So 94 degrees Celsius. So now we need to convert it to Kelvin. So we are going to add a 273 to 94 degrees Celsius, and then we're going to get, what we're going to get is 367. So that 367 is what we're going to write here. So we're going to write 367 kelvins. So here you cross multiply, then you multiply 473 with 367 divided by 309, and your final answer, the temperature, the volume must be 5V2 is equals to 562 kelvins if you do the calculation very well. And then from there we have another gas law, which is Avogadro's law, or we can just say a Gay-Lussac's law. So this law states that pressure of a gas is directly related to temperature at constant mass and volume. At constant mass and volume, the pressure is directly proportional to temperature, given by this formula, which is P1 over T1 is equals to P2 over T2. Okay, now let's look at an example. A gas pressure is 765 at 23 degrees Celsius. At what temperature will the pressure be 560 torr? So here, look, we have been given the initial pressure and the initial temperature, but we have been asked to find the final temperature given the final pressure. So we are going to use this same formula. Now let's derive our formula here. We have P1 over T1 is equals to P2 over T2. That's our formula. That's the formula that we are going to use. Okay, so to use that, we are going to replace the numbers now. So on our P1, we are going to have 765, as already stated there, over our T1 is 23 degrees Celsius. Now we need to convert that to, we are going to convert that to a Kelvin scale. So upon converting that 23 degrees in Kelvin scale, it is 296 kelvins, which is equals to, now our P2 in that question is 560. So we're going to write 560 over our temperature is what we're looking for. Our T2 may not been given, so we cross multiply here. Then we are going to multiply 560 with 296, and then we are going to divide with 765, and our final answer must be T2 is equals to our T2 must be equals to 217 kelvins. 217 kelvins. So that's all. Then we also have what we call ideal gas laws. So under ideal gas laws, we have the Avogadro's principle, which says equal volume of gases contain equal number of moles at constant temperature and pressure. Okay, so equal volume of gases contain equal number of moles at constant temperature and pressure, given by the formula PV is equals to nRT, where P is pressure, V is volume, N is the number of moles, and T is temperature. Okay, so P is pressure, V is volume, and then N is the number of moles, and T is the temperature. So let's now calculate. You see, let's have an example. Like for example, they are saying calculate the pressure in atmosphere. So remember this R, which is here, that R there, it's a constant. You are going to be given that. Okay, so it can be 0.08 to 1 in atmospheres per mole per kelvins. Yeah, so in atmospheres this R is 0.08 to 1, but at kilopascals it is 8.315. This is at when the pressure is in kilopascals, then it is 8.315, but if it is in atmospheres, then it is 0.08 to 1. So let's look at an example on how you can calculate problems using the ideal gas law, which is the Avogadro's principle. Okay, so we have this example here, which says calculate the pressure in atmospheres. So here I've been told that it is in atmospheres. So since it is in atmospheres, then we are going to use where R is 0.0, R is 0.08 to 1, where R is 0.021. Okay, now the question says calculate the pressure in atmospheres of 0.412 mole of heat 16 degrees Celsius and occupies 3.25 liter. Now let's go back to our formula, which is PV is equals to any RT. That's the formula that we're going to use here. So PV is equals to any RT, where T is temperature, R is the constant, and any number of moles, V is volume, and P is pressure. Okay, so that's what we're going to use. So we have the number of moles there, which is 0.412 number of moles, and then we have temperature, which is 16, and then our volume here is 3.25. Okay, so we have been told to calculate the pressure, to find the pressure. So we're going to use our formula. Okay, so let's replace in the formula now. So to replace in the formula, we have P, which is what we are looking for, and then volume is 3.25 liter, which is equals to number of moles. We have 0.412, and then R. So our R, remember, R is a constant you're going to be given. So if it is in atmospheres, then we use 0.0821. Then our temperature we've already been given in the question there. Our temperature is 16. Now 16, we need to convert it to kelvins. So when converting that temperature to Kelvin, we add 273. So when adding 273 to that, you must what you're going to get is you're going to get 289. So we're going to put 289 there in kelvins. That is 16 degrees Celsius in kelvins. Okay, now here, upon calculating this, if you do the calculations very well, the pressure is must be equals to 3.01 atmospheres. So that's how you can use the gas laws equations to solve problems. So thank you very much for this, for watching. Remember, don't forget to subscribe for more videos to come on science, chemistry, and biology. Thank you.